Water, it's a substance we often take for granted. It's essential for life as we know it. Every living organism on Earth depends on it. We drink it, bathe in it, and rely on it for countless everyday processes. From cooking to cleaning, water is indispensable. It seems so simple. Two hydrogen atoms bonded to one oxygen atom, H2O. Easy, right? But there's more to it than meets the eye. If only it were that straightforward. The simplicity of its formula belies the complexity of its creation. Creating water from scratch is a task far more challenging than its simple formula suggests. It involves precise conditions and careful handling. We can surround ourselves with buckets of oxygen and hydrogen. That's not enough. The process requires more than just having the right ingredients. Just because we can identify the ingredients doesn't mean we can easily combine them. The reaction is highly exothermic and needs to be controlled. The universe has rules, and making water requires more than just mixing these gases in a bowl. It demands a deep understanding of chemistry and physics. Imagine trying to build a house by simply throwing bricks and wood together. You'd end up with a chaotic mess, not a functional structure. Water molecules have their own specific stable structure. Randomly mixing hydrogen and oxygen is more likely to cause an explosion than a refreshing glass of water. That's because hydrogen is highly flammable. Oxygen feeds flames. Combine the two in the wrong way and you're essentially creating a miniature hydrogen bomb. This is not the kind of science experiment you want to try at home. Creating water requires overcoming an energy barrier. It's like pushing a boulder uphill. You need a significant input of energy to get the reaction going. Simply providing a spark, while potentially disastrous due to the flammable nature of hydrogen, won't create water. This energy input needs to be controlled and precise. Too little and nothing happens. Too much and you risk a dangerous release of energy, like in an explosion. This is why making water from scratch is a complex endeavor, even in controlled laboratory settings. Section 4, From Air to Water, Harvesting the Invisible. In this section, we delve into the fascinating process of extracting water from the air around us. Instead of forcing hydrogen and oxygen together, what if we could extract water that already exists in the atmosphere? This innovative approach could revolutionize how we think about water resources. Believe it or not, the air around us contains water vapor, even in arid environments. This means that even in the driest places on Earth, there is potential to harvest water. Harvesting this atmospheric water is a promising avenue for generating usable water. These devices can be a game changer in water-scarce regions. These devices, known as atmospheric water generators, work by cooling the air to the point where water vapor condenses into liquid water. This process mimics natural phenomena. It's like the way dew forms on grass overnight. The same principle is applied, but on a larger, more controlled scale. This technology offers a potential solution, especially in areas where access to clean water is limited. By harnessing the water in the air, we can provide a sustainable source of clean water for communities in need. Section 5. The efficiency problem. A drop in the bucket. While atmospheric water generation holds promise, it's not a perfect solution. Current technologies are limited in their efficiency. The amount of water they can extract from the air, especially in dry climates, is often insufficient to meet large-scale demands. Think of it like trying to collect rainwater with a teaspoon during a drizzle. You'll get some water, but it's not going to be enough to sustain a city. We need more efficient methods to make atmospheric water harvesting a viable solution for water scarcity. Section 6. A thirsty planet. The growing need for H2O. As we move further into the 21st century, the demand for clean, accessible water is becoming one of the most pressing issues of our time. The reality is that our planet is facing a growing water crisis. Many regions are experiencing severe droughts, and communities are struggling to access this vital resource. Population growth, industrial development, and climate change are putting increasing pressure on our limited freshwater resources. Urban areas are expanding rapidly, and industries are consuming more water than ever before. Remember, over 98% of Earth's water is salt water, which is not suitable for drinking or agriculture without extensive treatment, leaving only a tiny fraction readily available for human use. This small percentage must meet the needs of billions of people as well as countless ecosystems. The need for innovative solutions has never been greater. Engineers and scientists are working tirelessly to develop new methods to purify and conserve water. While making water from scratch might seem like a distant dream, researchers are exploring groundbreaking technologies that could make it a reality. Exploring every option, from atmospheric water harvesting, which captures moisture from the air, to more efficient desalination techniques, is crucial. These methods can transform seawater into drinkable water, providing a potential solution to water scarcity. The future of our planet depends on it. By working together and investing in sustainable water solutions, we can ensure that future generations have access to the water they need to thrive.